will study what is a linear combination, what is a linear independent, what are linear independent functions, and what are linear dependent functions. So first of all, linear combination is that can be written as it's basically a combination of scalars and the vectors or functions that are called here functions, and that combination equals to 0. So C1, C2, C3, C all Cn, all C's are scalars here. It can be, you can also write it a1, a2 and all that, and the vectors here are in along with the C1 we write it f1 of x. So here is the first function, and then f2 to so on. Along with the Cn we write it fn of x. So basically this is a linear combination, or we can say it is a sum of products of scalars and functions. So sum of products of scalars and functions, products of scalar and function, and it is the sum of products of scalars and function is called a linear combination. And if this linear combination, I am writing it as linear combination, so it is a linear combination. Okay, this combination is equal to 0, and then we will check that whether this linear combination is independent or not. If it is independent, then, or if the condition for independence is that if all the C, all means each and every C, all the scalars C1, C2, C3 to so on up to Cn are all C are 0, then the linear combination is called linearly independent, or the functions are called linearly independent functions. Linearly independent functions if all the C, each and every C, each and every scalar is a 0. Right, so that is linear independent function. And if any one of this C is not 0 and rest of the C is 0, like if C5 is not 0, a non-zero number, and all the C remaining C's are 0, then it is not linearly independent, it is linearly dependent. So if one C, if it is not linearly independent, then it is linearly dependent. So I am writing it is the word use, mathematical word use for this is for all, for each, that means each and every C, and here I am writing at least one, or there is a. So here we can write the symbol for all, and here we can use it. There exists at least one, there is any, there exists. So that means at least one, right? At least one C is non-zero, then it is linearly dependent function. It is not linearly independent function. So here is the minute difference you have to understand between the linearly independent function and linearly dependent function. So it's a very easy thing. You have to just remember that only if all C are 0, then it is linearly independent. So in the next video we will do some examples and check that the whether combination are linearly independent. We just guess, or we just assume that if the C's are 0 or not, and that combination makes it 0 or not, and with just hit and trial method we use that we check that whether the combination is linearly independent or linearly dependent.